All right, so we talked about how bigger size means more London dispersion forces and thus higher boiling points. But what about things that are of the same size? Are there any other useful information we can pull from this? And the answer is yes. So let's take a look at these 5 carbon hydrocarbons, right? So this is neopentane. You can see there's a central carbon with 9 other carbons around it. It has a boiling point of 9.5 degrees Celsius. This is isopentane. So still 5 carbons, same molecular formula. This is an isomer. You can see now that we have, instead of a central carbon connected to 4 things, we have kind of this 1 carbon on the end here. And so this boiling point is 27 degrees Celsius. And then we have regular N-pentane, which is just a chain of 5 carbons in a linear fashion, right? So there's no branching in this molecule. So this is N-pentane, and it has a boiling point of 36 degrees Celsius. So we can see that even though they have the same molecular formula, that when we go from left to right, we have more or a higher boiling point. So we have more intermolecular forces. And so what this is coming down to, because London dispersion forces need to make physical contact with one another to work, the more surface area you have to make that contact, the more or stronger London dispersion forces you have. So more surface area equals stronger London dispersion forces, right? And so same picture shown here. Same thing that I just drew. Right, with more surface area, you get more contact area, and then the more contact area, the more opportunities for London dispersion forces you have. So kind of fun fact for you here out of your book. This is how geckos stick to stuff, right? So geckos can stick to all kinds of stuff. And so they do that by using London dispersion forces and modulating how much surface area they have. So long story short, basically by kind of contracting their little toes, they can have these little feelers over here. And these little feelers can either have a lot of surface area or a little bit of surface area. So when they want to stick to something, they make their toes have a lot of surface area, and thus they stick to it due to all the London dispersion forces. And then when they want to pull their foot off of it, they contract it and they reduce the amount of surface area, and thus, you know, they don't stick to it. So, but this also explains why geckos can't stick to Teflon. Right? Teflon is made out of that fluorine, and it's too hard for the geckos to polarize it using their London dispersion forces.